Visit parthakachana.com for technology resources and stock analysis. List of 50 advanced level design patterns interview questions with detailed answers. 1. Can you explain the difference between composition and inheritance in the context of design patterns? Answer. Composition involves combining objects to form complex functionality by using objects' interfaces rather than inheriting from a class. Inheritance allows a subclass to reuse the functionality of a base class, often leading to more rigid structures. Design patterns like the decorator and strategy patterns favor composition because it promotes flexibility by allowing dynamic changes in behavior at runtime without affecting the codebase as much as inheritance does. 2. How would you implement a singleton pattern in a multi-threaded environment? Answer. In a multi-threaded environment, ensuring only one instance is created requires thread safety. One way to do this is by using double-check locking. The instance is checked twice, first without synchronization to improve performance, and then synchronized if no instance is found. You could also use a synchronized block or build Pew's singleton design using a static inner helper class which is inherently thread-safe due to Java's class loading mechanism. 3. When would you choose the proxy pattern over the decorator pattern? Answer. The proxy pattern is chosen when you need to control access to an object, such as providing lazy initialization, remote object access, or protection from unwanted access. For example, in a security or logging system, a proxy can control who or what accesses the object. The decorator pattern, on the other hand, is used to extend an object's behavior without modifying its core functionality. For example, adding new responsibilities to a graphical component at runtime without changing its original interface. 4. In what scenario would you use the flyweight pattern, and how does it impact performance? Answer. The flyweight pattern is useful when you have a large number of similar objects and need to reduce memory consumption by sharing as much data as possible. For example, in a text editor where each character is represented as an object, instead of creating thousands of individual character objects, you can use flyweights to share common properties, e.g., font style. This pattern improves performance by reducing the memory footprint, but may increase the complexity of managing shared states. 5. How would you differentiate between the builder and factory patterns, and when would you use each? Answer. The factory pattern is used when you need to create an object without exposing the creation logic and want to return one of several possible classes based on input. Factories often return objects that share a common interface. The builder pattern, on the other hand, is used to construct a complex object step by step, often for objects with numerous optional parameters. You'd use the builder when object creation requires many configurations, and the factory when choosing between multiple product types. 6. Can you describe how the observer pattern can be optimized for scenarios with many observers? Answer. In scenarios with many observers, the observer pattern can cause performance bottlenecks due to constant updates. To optimize this, you can use event filtering, where observers register interest in only specific types of events. Another optimization is batch notifications, where changes are queued and sent in batches rather than individually. Additionally, lazy evaluation can be employed, updating observers only when they actively request information, reducing unnecessary updates. 7. Explain a real-world use case where the chain of responsibility pattern would be appropriate. Answer. A real-world example of the chain of responsibility pattern is in handling customer support requests in a software company. Each request, e.g., bug reports, account issues, is passed through a chain of handlers such as Level 1 support, Level 2 support, and engineering. If a handler can't resolve the issue, it passes the request along the chain. This pattern is useful when different handlers need to handle the same request and the handlers are dynamically ordered or replaced. 8. How would you implement a thread-safe observer pattern? Answer. In a thread-safe observer implementation, you need to handle both the subscription/unsubscription of observers and the notification process in a synchronized manner. One solution is to use copy-on-write collections, such as copy-on-write ArrayList in Java, to manage observers. This ensures that while one thread is notifying observers, another can safely modify the list. You can also synchronize the subscribe and unsubscribe methods and use a read-write lock for the notification process. 9. What is the main advantage of the adapter pattern over modifying existing code directly? Answer. The adapter pattern provides a way to integrate incompatible interfaces without modifying the existing code, promoting open/closed principle. This allows you to reuse existing classes in different environments without altering them, which could introduce bugs or violate encapsulation. For instance, if you need to adapt a third-party library to your system, the adapter acts as a translator, minimizing the impact on your original codebase. 10. How can the command pattern help in undo/redo functionality in a text editor? Answer. The command pattern encapsulates requests as objects, allowing you to store and queue them for later execution, which is ideal for implementing undo/redo functionality. In a text editor, each user action, such as typing or deleting, can be encapsulated as a command. When an undo is requested, the editor can reverse the last command by calling its undo method. Similarly, redo can reapply the command. Storing a history of commands makes it easy to implement multiple levels of undo/redo. 11. Describe a scenario where using the state pattern would be more appropriate than using conditionals. Answer. A good example of using the state pattern is in a vending machine, which has different states like waiting for money, dispensing item, or out of stock. Instead of using large ifs or switch statements to handle each state, the state pattern allows the vending machine to change its behavior dynamically as its state changes. Each state is encapsulated in a class, and the vending machine simply delegates the task to the current state object, promoting cleaner code and separation of concerns. 12. What is the role of the memento pattern in data recovery or rollback scenarios? Answer. The memento pattern is used to capture and store an object's internal state so it can be restored later. In data recovery or rollback scenarios, the memento allows you to revert to a previous state without exposing the internal details of the object. For instance, in a database transaction, you can save the state before making changes. If the operation fails, the memento allows you to roll back to the initial state, ensuring data integrity. 13. How does the abstract factory pattern differ from the factory method pattern? Answer. The factory method pattern defines an interface for creating a single object, but lets subclasses alter the type of object that will be created. On the other hand, the abstract factory pattern provides an interface for creating families of related or dependent objects without specifying their concrete classes. While factory method deals with one product, abstract factory deals with a group of products. For example, an abstract factory might create UI components like buttons, menus, and windows for different operating systems. 14. In which scenario would you favor the visitor pattern over simply adding new methods to a class hierarchy? Answer. The visitor pattern is beneficial when you need to perform operations on objects of a class hierarchy without modifying the classes themselves. It allows you to define a new operation on an object structure without changing the code for the objects. This is useful when you have an existing class hierarchy that should remain unchanged and you need to add new functionality. For example, if you have a set of shapes, circle, square, triangle, and you want to add multiple operations like area calculation and perimeter calculation, the visitor pattern lets you add these without modifying the shape classes. 15. What are some potential pitfalls of using the singleton pattern in a large-scale application? Answer. Some pitfalls of using the singleton pattern in large-scale applications include global state. Singleton introduces global state, which can lead to hidden dependencies and make the application harder to maintain and test. Concurrency issues. In multi-threaded environments, improperly implemented singletons can result in race conditions or deadlocks. Tight coupling. Singleton can lead to tight coupling between classes, reducing flexibility and making code harder to refactor. Testing challenges. Singletons are difficult to mock or substitute in unit tests because their instance is globally accessible. 16. Explain the template method pattern and give a real-world example of its usage. Answer. The template method pattern defines the skeleton of an algorithm in a base class, but lets subclasses override specific steps of the algorithm without changing its structure. A real-world example is a workflow in an e-commerce system where an order can be processed. The base class might define the process as checking inventory, charging payment, and shipping the order. Subclasses can customize specific steps, e.g., premium customers get priority shipping, while the overall workflow remains the same. 17. How does the bridge pattern facilitate the separation of abstraction and implementation? Answer. The bridge pattern facilitates the separation of abstraction from implementation by creating two separate hierarchies, one for the abstraction and another for the implementation. This allows you to vary the abstraction and implementation independently. For example, in a drawing application, you might have different shapes, abstraction like circles and squares, and different rendering methods, implementation like vector and raster graphics. By using the bridge pattern, you can easily add new shapes or rendering methods without modifying existing code, enhancing flexibility and maintainability. 18. How would you use the strategy pattern to implement different sorting algorithms? Answer. The strategy pattern allows you to define a family of algorithms and make them interchangeable. To implement sorting algorithms, you would create an interface for sorting, e.g., sort strategy, with a method like sort list items. Each specific sorting algorithm, e.g., quicksort, merge sort, would implement this interface. The context, e.g., sort context, can then utilize the selected strategy to perform sorting. This way, you can easily switch sorting algorithms at runtime without modifying the context code. 19. What are some drawbacks of using the builder pattern for simple object creation? Answer. While the builder pattern is beneficial for complex object creation, it introduces unnecessary complexity for simple objects. Some drawbacks include overhead. It can add additional classes and methods for simple objects, making the codebase larger than needed. Increased complexity. Using a builder can complicate simple object instantiation where a constructor would suffice. Initialization order. Builders may require a specific order of method calls to correctly initialize the object, which can lead to errors if not handled carefully. 20. In what scenario might you apply the composite pattern? Answer. The composite pattern is applied when you need to treat individual objects and compositions of objects uniformly. A common scenario is in a file system where files and directories need to be handled similarly. Each file can be treated as a leaf node, while a directory can contain files and other directories. This allows clients to work with the entire structure as if it were a single object, simplifying the code when managing complex hierarchies. 21. How can the facade pattern simplify interactions with complex subsystems? Answer. The facade pattern provides a simplified interface to a complex subsystem, allowing clients to interact with a subsystem without needing to understand its intricacies. For example, in a home theater system with various components, TV, DVD player, sound system, a facade class can provide simple methods like watch movie that internally handles all the interactions with the components, turning on devices, setting the right inputs. This reduces client complexity and enhances usability. 22. Explain the use of the interpreter pattern with a suitable example. Answer. The interpreter pattern is used to define a grammar for a language and provide an interpreter to evaluate sentences in that language. A common example is an expression evaluation, where you can parse and interpret mathematical expressions. For instance, you could define an abstract expression class with concrete implementations for operations like add, subtract, and number. The interpreter would evaluate these expressions based on the defined grammar, allowing dynamic parsing and computation of expressions at runtime. 23. What is the significance of the observer pattern in implementing event-driven systems? Answer. The observer pattern is crucial in event-driven systems as it facilitates a decoupled communication mechanism where one object, the subject, can notify multiple listeners, observers, of changes or events. This allows different parts of an application to react to changes in state without being tightly coupled. For example, in a graphical user interface, button clicks can be observed by multiple components that need to react, like updating a display or logging actions. This promotes flexibility and scalability in event handling. 24. How do you ensure the proper usage of the strategy pattern to avoid code bloat? Answer. To ensure proper usage of the strategy pattern without causing code bloat, you should limit the number of strategies to only those that provide significant variations in behavior to avoid unnecessary classes. Use composition to delegate responsibilities rather than duplicating code across multiple strategy implementations. Focus on cohesive strategy classes that encapsulate a specific algorithm without incorporating unrelated behaviors, maintaining clarity and usability. 25. When is the use of the command pattern most beneficial in a user interface context? Answer. The command pattern is highly beneficial in user interfaces where user actions need to be executed, undone, or redone. For instance, in a text editor, each command, like typing, deleting, or formatting, can be encapsulated as a command object. This not only allows for the implementation of undo/redo functionality, but also supports features like queuing commands, logging actions, and even executing commands remotely, providing greater flexibility in managing user interactions. 26. Explain how the adapter pattern can help in integrating legacy code with modern systems. Answer. The adapter pattern acts as a bridge between legacy code, which may not adhere to modern interfaces, and new systems. By creating an adapter that implements the required interface while internally calling the methods of the legacy code, you can seamlessly integrate old functionalities without modifying the existing codebase. This allows new features to be built on top of legacy systems while maintaining compatibility, making it easier to extend or refactor systems incrementally. 27. What are the implications of using the decorator pattern for enhancing the behavior of objects? Answer. The decorator pattern allows you to add behavior or responsibilities to individual objects dynamically without affecting other objects of the same class. The implications include flexibility. It offers greater flexibility than inheritance because you can stack multiple decorators to combine behaviors at runtime. Adherence to single responsibility principle. Each decorator can encapsulate specific functionality, making the system easier to understand and maintain. Avoiding class explosion. It prevents a proliferation of subclasses by allowing behavior to be added on a per-instance basis rather than requiring a new subclass for every combination of behaviors. 28. Describe a use case for the bridge pattern and how it addresses the issue of class explosion. Answer. The bridge pattern is useful in scenarios where you want to separate an abstraction from its implementation, allowing both to vary independently. A classic use case is in graphic rendering systems where different shapes, circle, square, can be rendered using various methods, vector, raster. Instead of creating subclasses for every combination, which leads to class explosion, the bridge pattern allows you to define a shape abstraction and implement rendering separately. This way, you can easily add new shapes or rendering methods without modifying existing code. 29. In what situations is the state pattern particularly useful for managing complex behaviors? Answer. The state pattern is particularly useful in managing complex behaviors in scenarios where an object's behavior changes based on its internal state. For example, in a game character, states could include idle, running, and jumping. Instead of using numerous conditional statements to manage the character's behavior, the state pattern allows you to define a class for each state. The character delegates behavior to the current state, making it easier to add new states and transitions without altering the existing code structure. 30. How does the facade pattern improve the usability of a system for end users? Answer. The facade pattern improves usability by providing a simplified interface to a complex system, allowing users to interact with the system without needing to understand its internal workings. By offering high-level methods that encapsulate complex procedures, users can achieve their goals with minimal effort. For instance, in an online shopping system, a facade could provide methods like place order and track order, hiding the complexity of inventory management, payment processing, and shipping logistics, thereby enhancing user experience. 31. What are the differences between the visitor pattern and the composite pattern, and when would you use each? Answer. The visitor pattern allows you to define new operations on elements of an object structure without changing the classes of the elements. It is particularly useful when you have many unrelated operations that need to be applied to a set of objects. The composite pattern, on the other hand, allows you to compose objects into tree structures to represent part-whole hierarchies. Use the visitor when you want to add operations without modifying the classes, and use composite when you need to treat individual objects and compositions uniformly. 32. Can you explain the concept of the decorator pattern and provide an example of its application? Answer. The decorator pattern allows you to add new functionality to an object dynamically by wrapping it in an object of a decorator class. This is useful when you want to enhance an object's capabilities without altering its structure. For example, in a coffee shop application, you might have a coffee interface with a basic implementation. You can create decorators like milk decorator or sugar decorator that enhance the coffee object with additional features, like milk or sugar, while adhering to the same interface. 33. Describe how to implement the builder pattern for constructing a complex data structure. Answer. To implement the builder pattern, start by defining a builder interface with methods to build different parts of the complex data structure. Create a concrete builder class that implements this interface and keeps track of the product being built. The product is typically a complex object like a car. A director class can be introduced to construct the object using the builder, specifying the order of the building process. Clients will use the builder to construct the object step by step, resulting in a well-defined and manageable construction process. 34. What considerations should be made when implementing the observer pattern in a GUI application? Answer. When implementing the observer pattern in a GUI application, consider the following. Event management. Ensure that observers can efficiently handle events without causing UI lag. Use debouncing or throttling techniques when necessary. Memory leaks. Implement weak references or unsubscription mechanisms to avoid memory leaks caused by observers holding strong references to subjects. Thread safety. If observers are updated from multiple threads, ensure thread safety to prevent race conditions and inconsistencies in the UI. Notification efficiency. Optimize the notification mechanism to minimize performance overhead, especially when there are numerous observers. 35. How can the template method pattern be useful in establishing a framework for algorithms? Answer. The template method pattern defines the skeleton of an algorithm in a base class, allowing subclasses to override specific steps without changing the overall structure. This is useful in establishing a framework for algorithms, as it promotes code reuse while providing flexibility. For example, in a data processing framework, you might have a base class data processor with a template method process data, which outlines steps like read data, process data, and write data. Subclasses can implement specific data handling methods while benefiting from the established workflow. 36. When would you use the mediator pattern over direct communication between components? Answer. The mediator pattern is preferable when you want to reduce the complexity of communication between components in a system. Instead of having components directly reference each other, the mediator centralizes communication, promoting loose coupling. Use this pattern in scenarios like a chat application where multiple users need to communicate, but you want to avoid direct dependencies between user components. The mediator can handle messages, manage user states, and facilitate interactions, making it easier to manage and modify the system as it grows. 37. Explain how the prototype pattern can be beneficial in certain applications. Answer. The prototype pattern is beneficial in applications where creating new instances of an object is costly. Instead of instantiating a new object from scratch, you can clone an existing prototype. This is particularly useful in graphical applications where complex objects, like shapes or images, may require significant resources to create. By implementing the prototype, you can create a prototype manager that keeps track of various shapes. When a new shape is needed, it can simply clone an existing one, allowing for faster object creation while reducing resource consumption. 38. How does the chain of responsibility pattern facilitate processing requests? Answer. The chain of responsibility pattern allows multiple handlers to process a request without knowing which handler will ultimately handle it. Each handler in the chain either processes the request or passes it to the next handler. This pattern is particularly useful in scenarios where you have a series of processing steps, such as in a logging framework where log messages need to pass through different levels, e.g., info, warning, error, before being handled. It promotes flexibility and extensibility since you can add or remove handlers without changing the request handling logic. 39. What is the role of the flyweight pattern in memory-efficient design? Answer. The flyweight pattern is used to minimize memory usage by sharing common state among multiple objects instead of creating duplicate instances. This is particularly beneficial in scenarios where a large number of similar objects are created, such as in a text editor where many characters need to be rendered. Instead of creating a separate object for each character, the flyweight pattern allows you to create a single object for each unique character and share it among instances. This results in significant memory savings and improved performance. 40. How can you apply the singleton pattern while ensuring thread safety? Answer. To apply the singleton pattern while ensuring thread safety, you can use the double-checked locking mechanism. The idea is to check if an instance is already created before synchronizing the block that creates the instance. This reduces synchronization overhead. The implementation would look like this. Sample Java implementation. Public class singleton. Private static volatile singleton instance. Private singleton constructor. Public static singleton getInstance. If instance equals null, synchronize singleton.class. If instance equals null, instance equals new singleton. Return instance. This way, you ensure that only one instance is created and the method is thread safe. 41. What are the advantages of using the proxy pattern in system design? Answer. The proxy pattern provides a surrogate or placeholder for another object, enabling various benefits, such as control access. It allows you to control access to the real object, adding security or logging functionality without modifying the real object's code. Lazy initialization. You can defer the instantiation of a resource-intensive object until it is actually needed, improving performance and resource management. Remote proxy. It enables communication with an object that resides in a different address space, e.g., remote service calls, abstracting the complexities of remote interaction. 42. When would you consider using the visitor pattern instead of adding operations to existing classes? Answer. You would consider using the visitor pattern when you want to perform operations on a set of classes without modifying their structures. This is particularly useful when the object structure is stable, but you anticipate adding new operations frequently. You have many unrelated operations that need to be performed on the objects, leading to a proliferation of subclasses if you were to add methods directly. You want to separate the algorithms from the object structure, enhancing maintainability and flexibility. 43. How does the command pattern facilitate implementing undo functionality? Answer. The command pattern encapsulates a request as an object, allowing you to parameterize clients with different requests, queue operations, and implement undo functionality. Each command object stores the details of the action, like method calls and parameters. For undo functionality, you can maintain a stack of executed commands. When an undo is requested, the application pops the last command from the stack and calls its undo method, reverting the action. This promotes a clean separation of concerns, making it easier to manage complex interactions. 44. Explain the significance of the state pattern in designing complex state-dependent systems. Answer. The state pattern is significant in designing complex state-dependent systems as it allows an object to alter its behavior when its internal state changes. This eliminates the need for numerous conditional statements scattered throughout the code, improving readability and maintainability. For instance, in a TCP connection manager, the behavior of the connection, e.g., established, closed, listening, can change based on the state. Each state can be represented as a class, making it easy to add or modify states without affecting the overall system structure. 45. In what scenarios is it advantageous to use the strategy pattern? Answer. The strategy pattern is advantageous in scenarios where you have a family of algorithms or behaviors that can be selected at runtime. For example, sorting algorithms can vary based on data characteristics, and the strategy allows you to switch between them easily. You want to avoid using conditional statements to select behavior. The strategy pattern encapsulates each algorithm in its class, leading to cleaner and more maintainable code. You need to support varying implementations of an algorithm independently from the clients that use it. This promotes adherence to the open/closed principle, as you can add new strategies without altering existing code. 46. What challenges might arise when using the builder pattern in object creation? Answer. Challenges that might arise when using the builder pattern include complexity in builders. If the object being constructed has too many parameters or complex dependencies, the builder can become complicated and hard to use. Immutable objects. When working with immutable objects, ensuring that the builder correctly encapsulates all necessary parameters can be challenging, as changes cannot be made after instantiation. Fluent interface design. Creating a fluent interface, where method calls can be chained, can complicate the design, especially if the builder has many optional parameters or methods. 47. How does the chain of responsibility pattern improve code flexibility? Answer. The chain of responsibility pattern improves code flexibility by allowing multiple handlers to process a request without specifying which handler will handle it. This decouples the sender from the receiver, enabling dynamic handler changes. Handlers can be added, removed, or rearranged without altering the request processing logic. Separation of concerns. Each handler can focus on a specific responsibility, leading to cleaner, more maintainable code. Easier testing. Individual handlers can be tested in isolation, simplifying the testing process. 48. In what situations would you prefer the composite pattern over a flat structure? Answer. You would prefer the composite pattern over a flat structure when you need to represent part-whole hierarchies, such as tree structures. When dealing with tree-like data, such as a file system where directories can contain files and other directories, the composite pattern allows uniform treatment of individual objects and compositions. Complex relationships. When the relationships between objects are inherently hierarchical, using composite simplifies the client code, enabling easier navigation and manipulation of the structure. Flexible structures. When the structure is dynamic and can change at runtime, composite allows adding or removing components without altering the overall system. 49. Describe a scenario where using the flyweight pattern would be beneficial. Answer. The flyweight pattern would be beneficial in a text editor application that needs to render a large number of characters. Each character, like letters, digits, symbols, might have common attributes, font, size, style, while differing in their actual content. Instead of creating a new object for each character typed, the flyweight pattern allows the editor to create a single object for each unique character and share it across instances. This drastically reduces memory usage, especially for documents with repetitive characters, enhancing performance and resource management. 50. What are the advantages of using the adapter pattern in integrating new components? Answer. The adapter pattern provides several advantages when integrating new components into an existing system. Interoperability. It allows incompatible interfaces to work together by adapting the interface of a new component to the expected interface of the existing system. Decoupling. The adapter pattern promotes loose coupling by preventing changes to existing code when integrating new components, making it easier to swap out or modify components as needed. Code reuse. By enabling the reuse of existing components without modifying their code, the adapter pattern helps in leveraging legacy systems while transitioning to new architectures. Thank you for watching. Like, share, and subscribe. Visit parthakachana.com for technology resources and stock analysis.